Hello and welcome to the Innovative Studio. Guys, this is Shakil and today's lesson is about the pointers in C++. The agenda understands the core concept of the pointers, pointer concepts, theory, what is linked list, and then we will discuss the single linked list and double linked list. So guys, let's proceed. What is basically concept of the pointer? Basically in C++, pointer is special type of variable that store the memory address of another variable. Basically when we define a pointer variable, it holds the memory address, and that memory address can contain another value type variable which is stored on that address. So instead of holding the direct value, pointer holds the location of the memory where the value is stored. So it's very simple. Don't make it complex. As explained, that pointer is a type of variable which holds the memory address. Basically, then that on that address you can store a value type of variable that contains the value on that memory address. So let's proceed further with the examples. So guys, key concepts of the pointer variable. First of all, the address operator will be used that assigned to a pointer variable a value that will be stored using the address type of variable, that is also called the AND operator. So next is, first of all, let I told you that when you define a pointer variable, you points with the static, and it means you are going to define a pointer variable which holds the memory address, and then you can assign a value type variable on that uh, memory address. So you will assign that with the and sign and that variable of value type. So that value type variable will be stored on that memory address. So what's the difference in static pointer type difference operator, and the pointer address variable? Basically use the access, change the value stored memory, and the address point is point to, like int is the a type holds the 10 value and int p equal to the AND operator. So means that p is pointer type int variable defined, and a that AND operating using assigned to that variable on that address. So when you see out the pointer p, it will show you that the value of that address, pointer address. So when you assign the pointer equal 20, change the value via the pointer. So a, when you see out the a, it means that it holds the value type int variable. So this is the example that int x is a normal value type variable, int p defined as a pointer variable, and with AND operator x is assigned to that memory address. So cout p, it will show the pointers points to memory address location, and cout pointer p print the 10 value of the that pointer variables hold that value. So next, why use the pointer? Basically when you have to use the memory efficiently, then pointer variable use. Secondly, useful dynamic memory allocation. You can initiating by new and delete with pointers, and required for the address structure. So linked list, tree and graphs are the example of that data structure of pointer variable. Pointer enables function arguments by reference. You know there are two types of variable can be defined. One are the value types and other are the reference type variables. So pointer have ability to store these all variables. So using that you can manage the memory efficiently. Essentially, for the low level programming and hardware interaction, you can use the pointer variables. These are the uses of the pointers. So concept of the linked list, basically what is linked list? Linked list is the linear data structure. If you we have already learned about the array. Array is also a linear type, but instead of storing the element in continuous memory, each element is called a node of linked list elements called the nodes. So, and that is stored in the form of nodes. The data. Actually, data is contain or hold the values in type value or value types. And basically a node contain two parts. One is the data part and other is that the address part. So next is used for the address point to the next node of the sequence. The final node points to the null means that that is the end of the list. So in this way you can define a linked list. This is the simple concept of linked list. Guys, there are two types of linked list. So first of all, we will differentiate uh, in array and the linked list data structure. Basically, array is the continuous memory use the memory block. In array, there is you have constraints that you can't resize that one. And linked list is dynamic and the nodes anywhere in the memory can be stored and it has the dynamic size and you can easily insert and delete the nodes. So this is the that's why linked list is called the uh, better and efficient memory usage. So how basically a node is defined? Node is the structure, so you can see here node has two parts. One is the int part, stores the values, and another node is the next, points to the next node. With the null pointer at the end of the list shows that the linked list is ended. So there are two types of linked list, guys. One is single linked list. Each node has only one pointer next. Like example 10, 20, and 30 are the values and ends with the null. So it's the linear uh, linked list. Single linked list have only forward way. So there is second type which is called double linked list. Each node had the two pointers next and previous. So for example, in the start is null and then 10, 20, and 30 then end with null. So means that you can insert the node at the head and as well as at the tail. There are two ends, one is head and one is tail. And same way you can access the values in the forward way and in the backward way. So that is the uh, speciality of the double linked list. And the third type is circular linked list. The last node in the pointer connects to the back and the first node. So in this way, those nodes are connected in circular way. So that's why it's called a circular linked list. So operation on the linked list can be performed, guys. Insertion can be done, deletion, traversal, and searching. So add a note at the beginning, middle, and end. These the three types of uh, insertion can be done with linked list. Then deletion, remove of any node from linked list, and then traversal, go through the nodes and print them on whatever way, in backward and even forward and backward in case of double, and in the linear form only the forward way in the single linked list. Then searching also can be performed on the linked list. So guys, these are the operations which we can perform on the linked list. Let's move on to our practical side, and we can show you how we can perform these operations practically. So first of all, we will learn the concepts of pointer definition and types of pointer. Then we will uh, do the operations on single linked list and the double linked list. So let's move on to Visual Studio ID, and we will going to learn about the pointer variables. So guys, here we have defined our project. You know, it's our the 11th lesson of this series, and we are discussing the pointers. So guys, first of all, the single linked list, we will use that one, then and double linked list we will. Before we go on to the linked list, we will learn the concepts of pointer. So here is our one class we have defined regarding the pointer variables, which contain the different types of pointers. So uh, let's review this class and discuss the types of pointers. So guys, we have a pointer demo class. You can see here we have defined the private int value type variable here, and public the demo have the constructor int v, and we are assigning the value with v in the constructor. So you can see here we have a method show pointer types. So first type is null pointer, normal pointer, sorry. So with int static, uh, the variable name is the normal pointer. So we are defining here a normal pointer with static, and normal pointer, this is the variable name, and with AND operator we are assigning the value type to this memory address. So when we will print this one, normal pointer shows the value of null pointer, it will show the value, and then if with the static it will show the value from that address which have uh, um, assigned to that pointer. And if we want to see the address of that pointer, then simply we will uh, um, access that by using the normal pointer variable. So see out, this statement will show this one. Then second type of the pointer is null pointer. We have defined same way int static null pointer, but until unless we will not assign him a null value. This means that when we assign a null value, it means this holds the nothing. So we will print the null pointer value. When we will print, it will show nothing in the address. So that will be a type of null pointer. So guys, third type is the void pointer, that is the generic pointer. So you will define with the void word as we use the data type like wise, and then void pointer, and you will assign a value by equal sign and operator to this void pointer, can point to any data. Void mean you can assign any data type to this pointer variable. When we will print, it will store the address, and it will show here the address of that pointer variable. So need to, when you going to print the value of that one, so we need to be casting of that pointer variable into the type of variable, type of value which we are which we had stored in that, and it will shown by casting into So we are doing the casting here, if you can see here. So pointer has been cast into int, and then it will be printed the value. So next to that type of the pointer is the wild pointer. So guys, point this type of pointer, those pointer variables which are uninitialized. Like we have defined a int wild pointer. So we did not have assigned anything to that. So it means it contain a garbage value address, garbage value address, which is very dangerous and cause of the memory leakage. So we need to avoid this sort of definition of the pointers. These are the dangerous ones. So that's why we are not using normally this sort of pointer variables. So next to that, if we will see out this one, then we can see that this sort of value pointer does not contain or initialized, so it will be unpredictable values. So number 5, we have defined the dangling pointers after deletion and going out to be out of scope. So we have defined the int type pointer variable and assigned a value int 50. So when we see out this one, it will show the dangling pointer value here. And when we delete the pointer with the delete keyword and with the variable name, it will free the memory at that address will be free up, which we have stored that. And we will, when we delete the value, memory it freed up, and if we assign a null point to that, to prevent that, the dangling will be assigned a null. So dangling pointer after deletion reset to null. So we have done here this one. So next to that is guys smart pointer. That is the modern feature of the C++ uh, language, and it automatically manage the memory leakage and dangling issues. So when you define with the unique key, unique underscore pointer as a type of int, it manage the memory, and smart pointer is the variable name and assign the value 200. So it means when we see out this one, this smart pointer with the static will print the value of this. So guys, let's run this program and see what should be the output of this one. So we are going to run this one. Let's check. First of all, we will start from our main program and run it to console. So this is the breakpoint with F11 key we have entered into this show pointer type method. You can see here we have defined the value and assigned that to that pointer. Let's see what is the value printed on the console. You can see here the 100 value was assigned, and we have printed the value, and we have also printed the address of that pointer variable, which on that address our value 100 is stored. So this is the normal pointer definition and assignment, and then we have printed. So next is the null pointer. Let's see, we execute this one, and null pointer assign the null pointer value, and let's see what is the printed on the console. Now you can see here null pointer value is this one, and there is no address has been assigned to the null pointer. Null pointer mean no address assigned from the memory. So let's move on to the next one, and we have defined the pointer. Void pointer mean to say any sort of value type can be stored in this void pointer address. So we have assigned a value, you know, value variable contain the 100, and when we will see out, first it will show the address, stored address of the pointer, void pointer. So let's see. You can see here, this is the address of void pointer which we have defined. This is the address actually. And let's print the value, and value will be printed if we have casted that one. So let's see it and see the console. The 100 value after casting has been printed. This one has been printed. So move to the next one. Let's see. And we are going to define the dangling pointer. So we have first defined the void pointer, and wild pointer has been defined. So we have not initialized that one, means the wild pointer mean we have not assigned any value, and we can see what is the printed there. So this has been printed for this one. So next to that is our dangling pointer. So we have defined dangling pointer here and assigned the int value 50. So before we delete, we have printed this one, and you can see the value here. This is the value in dangling pointer which we was assigned before deletion. So now we are going to delete the pointer. You can see here our cursor is pointing that pointer is deleted, and now dangling variable pointer has assigned null value. When we print it, it will show the nothing into the console. You can see here it's a null value and it has been reset. So next to that, we are going to define the smart pointer. Basically, smart pointer are those pointer where it automatically manage the memory management. Done the memory may avoid the memory leakage and dangling issues. So we have defined this pointer. It is defined with the unique underscore pointer, and inside that we have told that int value will be stored inside that, and smart point ptr is the variable of this pointer, and 200 is the value assigned. And now we will see that how it will work in smart pointer case. So we are going to execute it, and let's see what happened in case. So it is worked here, and smart pointer value has been displayed. So guys, let's move on to our uh, those linked list part. So we will right now comment this one and comment out the single linked list example. Here is our single linked list example. We are going to see that one. So let's check it. Our single linked list. Basically, single linked list we will be use here, and let I show you how single linked list will work. So we need to check that why single linked list is we are getting that error. We will remove that, and then we will proceed with that. So basically we have commented that one. We'll uncomment it. Yes, it is commented, and I'm going to uncomment, and once it's uncommented, it will be here. And so we have comment out, and now we are going to run this single linked list operations. Before we run the program, let I explain it to you. Basically, our single linked list operations are here. What we can do with that? In the single linked list, we can insert value at head, and we can insert value at tail, and then again we can insert value on tail and even can head. So this will be managed like first node will be inserted value 10, then second tail will be inserted 20, then after 20 second tail value will be inserted 30, and at the head we will assign the value 5. So this will be print like this one. So we will check this one, and the single linked list is only traversed in the forward way. Then we can search the values in linked list. Here we are searching with the search method, and searching both two values like 20 and 40. If it will exist, will be printed found. If not exist, will be printed not found. So we can delete the value of linked list from any node. Node will be deleted where 10 value exists. Then we will again print this list, linked list values, and it will show that how many nodes have there and their values. Next to that, we are going to delete the 50 value from the node. If it will be exist there, it will delete, and otherwise it will show that not found. So these operations we will check how it will work. So let I run the program, and we see how it will work. So first of all, let's see linked list defined here, and this class, let me show you. This is the class. Basically this is the linked list class. So you can see here it contains two parts. We defined a node class publicly. One node part is the data part, that is int data, and next pointer node is point to the next node of that linked list. So in the constructor, we assign the value to data, and next pointer assign the null. So here is the linked list. So node defined as a head, and on the constructor we are going to assign head as a null pointer. So when we insert the value, we insert at head. If we had, then new node will be created here and assigned to the next, and head is assigned to that next node. And then if we insert at the tail, then you can see here the operations as well here. So node temp assign as a head, and while next it will be traversed, and until the null pointer it will be traversed, and next node will be assigned to that one. So with the end of null pointer shows that that is the end of the list. So delete node method will delete the value uh, where that node contain value that will be traversed and deleted. So next to that, you can see here we can search values in the node traverse. then search, and then show. If it exists, then we show the true found, and if not exists, then we return the false, that not found. So this display method traverses the array in forward way. It is a single linked list. So end of list null pointer shows that that is the end of the list. Then the deconstructor of this linked list will uh, reclaim the memory and will destroy the all memory, um, reclaim that, and garbage will be cleared here. So let's run it and debug it. So this is going to variable initial declared, then at the head uh, has been value inserted. Now at the tail, you can see here new node created, value assigned. If head is the null, then head assigned to new node. So no, it's not a null, then it means that we will traverse and until the found the null pointer. If that found, then next will be assigned to temp, and temp next will be assigned a node that at the tail. So now we are going to assign the value at head. So you can see here new node created, value has been assigned passed to that node, and the new node is we have to assign the new value at the head node. So that is assigned there and had assigned a new node here, you can see here. Now we are going to display the all values in that linked list. So with using while, the values until unless not equal to the pointer null, so mean when null pointer will be reached, all values has been retrieved and shown. So let's see what we have traversed. Come here on the console. So our linked list contain 5, 10, 9, 30, and end of the linked list null shows that that is the end of the linked list. So next to that, guys, we have to search value. So for that, the search method is called from here. So head is assigned to the temp node variable, and when temp is not null, if data in the temp is equal to value, it will return true. So until unless it will not be true, it will be traversed. So let's see. Now the data has found and value has been find there searched, and you can see here what printed on the console. So 20 has been found in the list. You can see here it exists here, and that's why printed the found. Now we are going to search the 40 value, and it will not be found because you can see we don't have 40 value in the linked list. So not found has been printed here. So next to that, guys, operation is delete. So we are going to delete the 50 value on the linked list node. If it is, that is not exist there. So first we have deleted the value 10 on the node, and let's see after deletion what is the status of linked list. So you can see here value has been deleted and we have three nodes now. First we was 4 and now 10 is deleted, and the linked list contain now 3 nodes, and that is the end of list with the null. So this is the deletion of 10 value on that node. Now we have deleted the 50. Let's check what is the result there. So value not found in the list. So 50 was not there, that's why it is not found and not deleted. So next we have displayed again list, and you can see here same status of the list because 50 was not present in the linked list. So guys, this is our operations of single linked list, and after this we are going to discuss the double linked list. So guys, basically you can see here single linked list can be traversed only in a forward way, but double linked list can be traversed in both forward and backward way. And let's see how it will work. So first of all, I'm going to comment this single linked list code calling, and also will comment the single linked list class. So once I will comment it, let's move. So this has been commented, and we are going to discuss the double linked list. You can see here our class right now is commented. I'm going to uncomment that, and then we'll discuss the functionality of this first, and then we will run it, execute it, and see what are the outcome of this one. So guys, let's check it. So we have uncommented this, and in the our main we also uncomment our calling from main void function. So let I first explain you how it will work. So guys, this is our main method. We have defined the double linked list variable with DLL, double linked list mean, then inserted at the head 10 value, then at the tail 20, then at the tail 30, and then inserted at the head 5. So same way we have inserted that. What is the difference in this one? That you can insert the value in both head and tail, like linked list, single linked list, but you can display forward and can display in the backward way that. So then we can delete the nodes, we can display forward, we can delete the node, and then we have performed the same operations in that one. So let's check. First we will insert all these nodes. You will see the order will be forward way 5, 10, 20, and 30, and then will be in reverse order 30, 20, 10, and 5. Then we will search the all values, and then we will delete the node. Then again we will traverse it double linked list in forward way, then delete the node 30 and will display in the forward way. And then we will also display it in the backward way. Let's run it and see the output. So guys, this is, let's first I will close the previous console so there will not be any confusion for that. Let's run it now, and this variable created first node we have inserted, head is null, then new node inserted, and tail assigned to the head, and then tail assigned a new node, that is our insertion at the head. So let's insert on the tail, and the tail we have created new node, tail assigned null pointer, head assigned tail, and on the tail we have assigned the new pointer. Else, in case if uh, the tail is not null, then tail assigned next node and next node assigned to the that new node. So in the previous node, tail has been assigned to the node and tail equal new node. So move tail to that pointer. So in this way, we have assigning the value on head and the tail. Now we have going to display the double linked list in forward way. We are traversing and let's check what are the values there. So you can see 5, 10, 20, 30 in the forward way, and next to that we are going to display it in the backward way. Let I run it with F5 and let's see how it will work for the backward. So values will be displayed in reverse order. You can see here these value has been in reverse order, that is the backward, traversing and displaying. So we are going to perform the next operation, search. Search will be done. We are going to search the 20 value in the linked list. Let's check if it is found or not. So true has been returned, means that we have found that value, and you can see here value has been found. So next we are going to find the 40. If 40 is exist, no, 40 is not in our list. The expected result is false and not found. You can see, let's check. Yes, not found. You can see here. So let's move on to next one. We are going to delete the value 10 at the node. It will be a second node. So let's execute it. This has been deleted and nodes has been accordingly arranged. Displayed the values, one node deleted, no three node will be there, and you can see in the forward way the values are there. 5, 10 has been deleted, 20 and 30 present there. Now move next, and we are going to delete the value 30. 30 is there and it will be deleted, and again in the forward way linked list will be traversed. You can see here, and it's there in 5 and 20. Two nodes has been deleted, that is the 5, 10 and 30. So only 5 and 20 there. Now we will display it the backward way. So you can see here it is displayed in backward way. So here comes that backward. So guys, this is all about the our pointers and linked list. Today we have discussed that our pointers, types of pointers. We have discussed the single linked list. We have discussed the double linked list. We have discussed the operation, insertion. We have discussed the deletion, search, and for the single linked list, uh, we have only forward way, and in the double linked list we have both ways. Drivers can be forward and backward, and we have also deleted the node from linked list. So guys, that's all from today's lesson. So thank you very much for being with us, and keep watching the my videos, keep learning, and give me your opinion on this so we can improve it. So thank you so much, and bye bye for now.